JEE MAIN 2026, 2nd April Shift 2, Physics Section A, Question 44. Let us visualize the bismuth 209 nucleus. It contains 83 protons, shown in red, and 126 neutrons, shown in blue, tightly bound together. The binding energy per nucleon curve shows how tightly nucleons are bound in different nuclei. Iron 56 sits at the peak with about 8.8 MeV per nucleon. Bismuth 209 is a heavy nucleus that lies on the descending part of this curve, with a binding energy per nucleon of approximately 7.84 MeV. The question states, the binding energy per nucleon of bismuth 209 with Z equals 83 is blank MeV. We are given, mass of bismuth 209 is 208.980388 atomic mass units, proton mass is 1.00782 U, neutron mass is 1.0086665 U, and 1 atomic mass unit equals 931 MeV per c squared. The options are A, 7.48, B, 7.84, C, 8.79, and D, 6.94. The key concept is mass defect and binding energy. When individual protons and neutrons come together to form a nucleus, some mass is lost. This lost mass, called the mass defect, is converted into binding energy that holds the nucleus together. The mass defect equals Z times the proton mass plus N times the neutron mass, minus the actual nuclear mass. The binding energy equals mass defect times 931 MeV per atomic mass unit. And the binding energy per nucleon is simply this total binding energy divided by the mass number A. Step 1. Bismuth 209 has Z equals 83 protons and N equals 209 minus 83, which gives 126 neutrons. The total mass of the constituents is 83 times the proton mass plus 126 times the neutron mass. Computing this, 83 times 1.00782 gives 83.649475 U, and 126 times 1.0086665 gives 127.091790 U. Adding these, the total mass of parts equals 210.741265 U. Step 2. The mass defect equals the total mass of parts minus the actual mass of bismuth 209. That is 210.741265 minus 208.980388, which gives a mass defect of 1.760877 atomic mass units. The binding energy equals this mass defect times 931 MeV per U. After calculation, the total binding energy comes out to be 1639.376 MeV. Step 3. Finally, the binding energy per nucleon equals 1639.376 divided by 209. Solving this gives 7.844, which is approximately 7.84 MeV per nucleon. The binding energy per nucleon of bismuth 209 is approximately 7.84 MeV. The correct answer is option B. Here are some exam tips for nuclear binding energy problems. Memorize these three formulae: mass defect, total binding energy, and binding energy per nucleon. Always use the atomic mass for the proton, which is 1.00782 U, as it includes electron masses. Remember that 1 atomic mass unit equals 931 MeV per c squared. The binding energy per nucleon peaks at iron 56 with about 8.8 MeV. For heavy nuclei like bismuth, the value is typically between 7.5 and 7.9 MeV per nucleon. Like and subscribe for more JEE Main solutions at MAGPIEHUB.